Hi guys, my name is Haruki. I'm the driver and builder of 901Z,
And I'm Olawan. I'm the team captain as well as the main programmer for 901Z.
and this is our robot explanation. I'll start with the drive base. We ran a pretty standard drive base. 6 Blue motors, 450 RPM. We had traction wheels here because we wanted to avoid side-to-side movement during autonomous routines, and also it helps with line to long goal so we don't get pushed off the long goal easily or the mid goals. We had a 36 tooth gear here since we wanted to fit a full C-channel horizontal brace here. We had problems with drilling high strength axles, especially the long ones, the new ones. This is an old high strength axle, so this one worked, but when we tried to do full high strength axle brace, it often bent a little bit, so we decided to go with the consistent and lightweight C-channel. However, this meant that our sleds have to cover the C-channel brace here, which meant that our parking was pretty inconsistent because the park zone had to go over here, which means that sometimes, since the wheels didn't touch the ground and the front part of the robot was floating, we couldn't park or we got stuck sometimes. Now I'll move on to the intake. Our intake is pretty much a copy of Snacky Cakes. All the roller sizes are the same, where we have front stage intake. We took inspiration from 1010G using a 3-wide C channel so that the intake structure remained secure and we didn't have to have L channels supporting it. And then the intake is powered by 2 Blue motors. And the first 3 rollers, these 3 rollers here, they're powered by the first Blue motor. And then the top 3 rollers here, they're powered by this Blue motor here. And aside from the very first roller, which is geared down for more speed, and also the top pivoting roller here, which is also geared down for more speed, all the other rollers are running at 600 RPM. I think these are running at 900. And then I'll also talk about the pivoting hood. We had a 3-stage hood that was first to enter the hoarding stage. We lifted the wing so that the hood would come down here so that we could store blocks. To score, then the wing would come down and we could score properly. And then for our local, the pivoting scoring mechanism, it would get retracted with this piston here, and the string here would pull down the hood too, so the blocks wouldn't fly out. And now I'll be moving on to our aligners. We had a large middle goal aligner here. This was very nice since it helped with our autonomous routines and also in general driving. And here we also have the top goal D-score. This was really helpful since we could D-score with just one block and gain control. Now I'll also move on to the wing aligner. We had 2 PCBs here so that we could wing more consistently from the front, but our main issue with this wing aligner, it kept on riding onto the long goals, which meant we got stuck in many of the matches and we lost many of the matches since we couldn't wing properly. Another issue with our robot, primarily, the reason we lost so many matches during Worlds was that our center of gravity was way too high. As you can see here, we have attached a lot of Gen 2 or like the newer solenoids and also our air tank toward the top, which meant whenever we wing, our robot would just like swing from side to side, or it would tilt a lot, and then we actually tilted and fell in some matches. Additionally, our wing, it was not like straight, it was not parallel to the floor, so that sometimes when we winged, the wing would get stuck or it would tilt up the robot like this. So, because that's just one of the issues of mounting the wing on the tilted snacky C channel here. And this is our PCB long goal liner. One of the issues we had with this was since this PCB often bounced off, and this affected our autonomous routines, which Milan will talk about more.
Okay, so for autonomous routines, we mainly used an odometry pod right here. This is just useful for tracking, and we also installed an IMU right underneath the C channel. As you can see. Oh, sorry. And then we also used distance resetting. So although we didn't have that much opportunity to use distance resetting, as this was a very last minute change that we had as a team. We have distance sensors on on every side of the robot. So there's 2 here, as well as 1 in the front, as well as
Yeah, one right
yeah,
there.
yeah, 1 right there. So the main issues that we had about in Vex Worlds was that the new tiles were they had less friction, so our robot constantly overshot when it comes to autonomous routines. So what we had to do is, in the practice fields, we had to adjust our coordinates by changing our code. And I was just wondering, like, if maybe our PID could have been tuned a little bit more, as there's still a lot of inconsistencies within the changed coordinates. So if you guys can have any feedback for that, that would be great as well.
Yeah, in general, we're still pretty inexperienced team. That's why we tried our best to replicate the Snacky build, but there are many flaws with our build quality. So if you guys have any feedback, please let us know. Yeah, thank you.
Yeah, and then see you guys in Override. I gotta sit here. Okay, let's go.